Okay, so I want to look at a few of the homework problems from 6.4, our chi-squared distribution. So the first one here, we want to find the chi-squared left and chi-squared right, these critical values for the particular sample size that they give. Okay, so for some reason I lost my screen there for a second, trying to get to the e-text. So in in the back of your textbook or your formula cards, I just go right to the e-text on here, and you can look at the tables, and you'll see you have the z distributions, the t distribution, and then finally this chi-square distribution. So let's keep in mind what we're looking for here for this particular chi-squared value. We want 90% confidence. So when we have 90% confidence, remember that that's 5% in each tail. I'll show you what I mean. So anytime, now I'm going to try to draw a chi-squared, kind of skewed right distribution, but if I have 90% in my interval, okay, try to keep in mind that that would leave us with 5% in each tail. Okay, that's what we mean by 95% or 90% confidence. You still have that 5% in either tail. So this is telling us that we have a sample size of 21, so that's going to be 20 degrees of freedom. And I want to go find chi-squared right. So let's look at that table. So to find my chi-squared right, the right-hand odds that would have 5% in the tail, I'm going to go down to my sample size is 21, so I want 20 degrees of freedom. And it looks like that would be 31.41 for 20 degrees of freedom. Let me just double check my degrees freedom on that one. Yeah, n is 21, so that's 20 degrees of freedom. It's always n minus 1. Okay, so we have 20 degrees freedom, and then we're going to have 5% in each tail. So if I go out to find my chi-squared right, there would be 5% in that tail. So that would be 31.41. Not letting me submit my answer here. Let's see. There we go. Check answer. Okay. And then we want chi-squared left. So think about for chi-squared left, you have 90% in the interval plus another 5 in the tail. So you're going to look for 95%. I know we want a 90% confidence interval, but we're looking for a total area of 95 that's under the curve. So I go down to 20 degrees freedom again, and I'm looking under the column of 0.95 now, not the 0.9 column, not a confidence level. So it's good. You got to think about the area that's in the tail. So 10.851 looks like. So when we're making these confidence intervals for variances and standard deviations, that's really the first step, is to get that chi-squared left and chi-squared right. So let's look at another one. Once we get these two values, getting the chi-squared interval is not as difficult. Okay, so my recorder's still going. We're good. Okay, so now we want 99%, and we have 25 degrees freedom. So when it's 99% that's in the interval, think about what's in each tail. You don't have 1% in each tail. That would be 98%, right? There's two tails. So if there's 99%, there's 1% total left over. You divide that by 2, you have 0.5% in each tail. Okay, so let's remember our degrees freedom is 25 now. So I go down to 25 degrees freedom. Trying to scroll down to that on my screen. So 25 degrees freedom. My chi-squared left is going to be right here. That's at 10.52. To get the chi-squared right, we slide all the way out here, farthest to the right that we can find. It looks like it reads 46.928. Oh, they changed that up on me. They wanted chi-squared left first. So let me go back and reread that. 25, so 10.52 is my chi-squared left. 10.52. And now they ask for chi-squared right. So watch that. They switched the order of those. Almost fooled me there. Chi-squared right is going to be 46.928. Okay, so that's the first step. Now when we look at, let me jump ahead to number 6, for example. You can see how we would compute one of these intervals from start to finish. Right in our lecture slides, you have your formula for that chi-squared interval. We take basically our degrees freedom times the sample variance, or sample standard deviation squared. And you'll have this formula in front of you, but just you want to be careful because notice the chi-squared right value is on the left endpoint of the interval, and chi-squared left is on the right. So don't let that confuse you, but just make sure you have the formula sheet right in front of you. Okay, so let's look at what they give me. They give me the variance. They give me s squared. It's 24.01. They give me n. I'm going to use n minus 1. And then we're just going to have to go look up our chi-squared left and our chi-squared right, just like we just did previously. So you're going to have basically two things here, right? We have our n minus 1. They give me n is 27. So we're going to have 26, okay, times the sample variance. And that sample variance is 24.01. Okay, and I'm going to do that twice. Okay, this is where sigma squared is going to live. Do the same thing twice. 26 times 24.01. Okay, and over here, this is going to be chi-squared left. And over here to the right, this is where chi-squared right will be, and this will be chi-squared left. Okay, they're in opposite spots of what you would expect, right? Chi-squared right is over to the left, chi-squared left to the right. So we have to go look those up. Well, we have 20. We want 95% confident, and we have 26 degrees of freedom. Okay, so for 95% confident, I don't look in this column. I'm going down to 26. I want to be in the 0.975 column. Okay. So that's my chi-squared left, 13.844. Okay, and then we go look up our chi-squared right. So for 95% confidence, we'd have 0.025 in the tail. And I go down to that 26 degrees of freedom. Looks like it reads 41.923. Okay, so now it's just really a calculator deal at this point. We're going to take 26 times 24.01. And then we're going to divide that by chi-squared right, 41.923. Remember, you're dividing by a bigger number, so you get a smaller number. So that helps make sense of it. And now I can just hit second enter and just change that 41.923 to 13.844. Okay, so those will be my two endpoints, and I think we go to one or two decimal places here. Let's see, 14.89. And the other end of that interval is 45.09. Okay. So let's do, we'll do one more of those. Make sure we get the hang of that. But you're looking up, oh shoot. So this is the population variance. So the standard deviation would just be the square root of each of those, right? So I would take the square root of 14.89. And I want to take the square root of 45.09. Alright, so I get 3.86. And then 2 decimal places on my other guy, 6.71. Okay. Alright, so let's look at one more of those. Question 8. So the reason I wanted to do 8 is because they give us the actual numbers, and this would be, we can't put them in our calculator, like I've been suggesting with these homework problems, is to go ahead and open this up in StatCrunch. Oops. StatCrunch not cooperating with me. Okay, so that time StatCrunch decided to cooperate with me. So under the stat button here, we have our proportion stats, variance stats, right? This is what we're working with right now. We have a 1 sample, and we want a confidence interval for the variance. So what do we have here? We actually have the data. We don't have the summary statistics. If they gave me the summary statistics, I can run it on StatCrunch right from there as well. So I have the data. So I'm just going to tell the StatCrunch to use that variable 1. Hypothesis test will be in the next chapter. And let me just double check what confidence level we wanted here. 99%. So we have to tell StatCrunch to give us that 99% interval, and then we can go ahead and compute. Okay. So this is the confidence interval for the variance. All right. It goes from, and we would take the square root of each of these limits to get the standard deviation. So I have 0.03725. Three decimal places, that would be 0.037. Right? And then 0.248. Okay. And we can actually do when it says when you're working in StatCrunch, if you want to do the previous problems, like if you wanted to do number was it 4, where we have the sample statistics, you can probably do that. You can probably just tell the calculator, or no, 4 is where we have to get our chi-squared left and chi-squared right. But if I have a confidence level, they give me the variance and they give me the sample size, StatCrunch can probably open that for you. You just don't have the option here. There it is, there's StatCrunch. Okay, so if I go to stat variance statistics, 1 sample, oops. And this is where I say with summary, okay? What's the sample variance? It's 16.81, okay? What's the sample size? 30, okay? We want a confidence interval, 95. And we just compute it, okay? So the big thing to remember though is that standard deviation is the square root of the variance. So once you get variance, if you need standard deviation, you're just taking the square root, okay? And so that's not that's not a new concept. Standard deviation is square root of variance.